So today we're going to continue with composite shapes, specifically composite shapes challenges. So if you want to turn to your page, notebook. Okay, so these ones are going to be pretty challenging. I want you to go through and try each of them. But if you don't get them right on your first attempt, that's totally fine. I just want you to try them and see if you can understand them. They're going to be kind of tricky, and at times they might try and confuse you. And on a lot of these, they're not actually asking specifically for the area, but you have to find the area in order to find what they're asking for. And so that's going to be the hardest part about all of these. And so even when I went through, there were a couple times where I put in my answer and it would give me an error message, and I'm like, oh wait, I made a little mistake, like I accidentally added wrong, or oh wait, that's not what they were asking. So if you get a 0 on this, but you really try and you work hard, cool. I just want you to work through them and really try your best. So let's start with this first one. We're going to draw a kind of net shape. So if you want to draw a square, and then off of each 4 corners, we're going to draw a rectangle. Okay. And then they told us that this was 20, this was 20, this side here was 12, and then this side here was 12. And then they asked us to find the area of the whole shape. So let's go through first and try and figure out what the other sides might be. So if this is 20 and this is a rectangle, I know that this is also 20, which means this is 20, and which means this is 20. So all these are 20, and then same thing going this direction. If this is 20 and it's a rectangle, this is 20, this is 20, and this is 20. Okay. So then they said that this was 12, which means that this here is also 12. They said that this is 12, which means that this here is also 12. And while it doesn't necessarily say that these other ones are 12, we're going to assume that since this is 20 and these kind of look the same, that this here is going to be 12, this is going to be 12, 12, and 12. And when you see it on Khan Academy, or if you get this problem, you'll be able to identify, like, oh yeah, obviously if this is 12, this is 12, and so on, just based on the way it's drawn, but I'm no artist, so it doesn't really look like that. So when you have a composite shape like this, you're going to break it up into pieces and find the area of each piece and add them together. Luckily here, the way it's drawn, it's already broken up for us. So let's start first with the rectangle, or the square in the middle. So that one is going to be a 20 by 20, which is going to be 400. Then we have each of these, which look like they're 12 by 20, and we have 4 of them. $12 times 20 is going to be 240. And when I add all of that together, I get 1,360 as my final answer. Okay, let's do another one, and let's do one that kind of more involves a story problem. So Anton is paving a parking spot. It cost $40 to pave each square meter. Find the cost of the parking spot. Okay, and so then for this parking spot, we're going to draw a parallelogram. And this is where the car is going to go. I'm not going to draw a car because you don't want to see that. And then it was also kind of drawn like this. And they tell us that this here is 6 2/3, fractions everyone's favorite. And this here is 3. Okay, so we first need to find the area before we can figure out the cost. So our final answer is not just going to be the area of this space, it's going to be the whole cost of the parking spot. So to find area of, this is a parallelogram, we're going to do base times height. So we're going to do 6 2/3 times 3. Now, 6 2/3 can't really be rewritten as a decimal because it's a repeating decimal. So in order to multiply these, we really need to keep it in fraction form. I can't multiply something as a mixed number, so I first need to convert it to an improper fraction. So to convert it to an improper fraction, you're going to multiply your denominator times the whole number, and then whatever you get there, you add it to your numerator. So I get 3 times 6 is 18, plus 2 is 20, over 3. And then whenever we have whole numbers in our multiplication, it's always just easiest if you write them over 1. That way you don't think it's 20 times 3 and 3 times 3. So now I can multiply. When I multiply fractions, I multiply across. So here I get 20 times 3 is 60. 3 times 1 is 3. 60 divided by 3 is going to be 20. So this space here is 20 square meters, but they didn't ask us to find the area, they asked us to find the cost. So now what I'm going to do is multiply my area times my $40 per square meter, and my final answer is now $800 to pave this parking spot. So this one was kind of tricky because first it was fractions, but also your answer is not the area, it's the cost, so it's a multi-step story problem. Okay, let's do another one. Susie is cutting a 1 1/2 meter by 3/4 meter piece of rectangular paper. Into 2 pieces. Cut along its diagonal. Find the area of each piece. Okay, so let's first draw this out because I think that that will be helpful in terms of solving. So it's just a rectangle. And then they said that its dimensions were 1 1/2 by 3/4. So this is going to be our 1 1/2. And then this will be our 3/4. And then it said that they cut it along the diagonal. And we want to find the area of each piece. So what we're finding here is the area of a triangle, and our triangle is 1/2 base times height. So all that I need to do now is find the area if this is my base and this is my height. So I have 1/2 times 1 1/2 times 3/4. Here I have a mixed number, which I can't really have, so I'm going to rewrite this without that. So again, I multiply and I add to convert it. So my new problem becomes 1/2 times 1 times 2 is 2, plus 1 is 3. So times 3/2 times 3/4. So if I multiply, 3 times 3 is going to be 9. 2 times 2 is 4. 4 times 4 is going to be 16. These two numbers here share no common factors. So this here is going to be my final answer. Okay, let's do one more example. And I'm going to skip the story problem part of this, but what I want you to draw is a parallelogram that looks kind of like this. And then we're going to divide our parallelogram into 4 pieces. So we're going to go up to here, down, and up. And let's say that the area of the whole thing is 1,600, and the height of one of these pieces is 80. And we want to figure out the base of one of these pieces. So the whole thing is 160. It's divided into 4 equal sections. We want to find the base of one of them. So there's a couple different ways that I can solve this. One thing that I can see just by looking at this is half right here. So I already know what the whole thing is. It's going to be half. So it's one way that I could solve this. So I could figure out, okay, 80 times what is 1,600 and cut that in half. or I can find the area of one piece and then use that to find the base. And so I'm going to do that way. I'm going to find the area of one of these pieces and then knowing that my height is going to be 80, find the base. So if the whole thing is 1600, when I divide it into 4, I get 400, which means that each of these pieces is going to be 400. So now I just need to find the area of one of them. And this here is a triangle, so my area formula is going to be 1/2 times base, I don't know, times height, which is 80. And the area that they gave us is 400. So now it's just like our triangle solving problems. And so I'm going to do 1/2 times 80 is 40. So I get 400 equals base times 40. So base times 40 is going to give me 400, which means my base needs to be 10. So then the other way that I could have done this is I know here my height of my parallelogram is 80. My base is going to be, so let's say if we did this the other way. So my height, if I have parallelogram, area is base times height. I know my area was 1600. My height was 80. And I'm trying to figure out my base. So 80 times 20 is going to be 1600. And then, since it looks like it's half of it, I'm going to divide that in half, and I would get 10. So in both situations, whether or not I found the area of the whole thing, or found the base of the whole thing and cut it in half, or found the area of one piece and used that to find the base, I get the exact same answer. I get 10 for both of them. So there's multiple ways to solve each of these. It's just up to you how you see it and which way you think is going to be easiest to solve.